In this lesson, we're going to learn about reflections in the coordinate plane. So, a transformation that flips each point of a figure across a line is called a reflection. So, basically, we're going to talk about what that does to the ordered pairs. We've already kind of looked at in class what it looks like when you flip a figure over a line. We're going to talk about on a coordinate plane what happens to the ordered pairs. If you reflect a figure over the x-axis, what happens to the ordered pair is that x stays the same and y becomes the opposite. So we would say negative y. If we flip a figure over the y-axis, the x would become negative and the y stays the same. And if we flip both at once, so that means if we flip it over the x-axis and then the y-axis or vice versa, both the x-coordinate and the y-coordinate would be the opposite. So this is what it would look like. Let's say the ordered pair was 2, 3. If I flip it over the x-axis, the x value, the 2, would stay the same, but the 3 would become the opposite. So the opposite of a positive 3 is a negative 3. If I flip that same 2, 3 ordered pair over the y-axis, the x would become the opposite. So 2 is positive, it'd become negative 2, and the y would stay the same. So the y would stay a 3. If I flip it over both at once, if I flip it over the x and then the y, they both would become the opposite. So it would become negative 2, negative 3. We're going to look at that a little bit closer when it comes to graphs of certain figures. All right, we're going to look at this figure here, this SRQP, and we're going to reflect it over both the y-axis and the x-axis and see what it's going to look like. Now, starting with the y-axis, if we remember that the rule is the negative x value and then y, negative x just meaning the opposite of x. So, if that rule holds true, point P, which is negative 2, 3, the x value, which is negative 2, would be the opposite. The opposite of negative 2 is positive 2. So if this rule holds true, it's going to be positive 2, and then the y value stays the same, so it would be positive 3. So I'm going to plot over 2, up 3, and I'm going to label this P prime. Now, I want to kind of count and make sure that this is correct. P is 1, 2 spaces away from the y-axis. If P prime is correct, it will also be 2 spaces. So, 1, 2. That is correct. So now I'm just going to follow my rule. The x value becomes the opposite, so negative 2 turns to positive 2. And then the y value, the 1, stays the same. So over 2, up 1, and that's point Q, so it's going to be Q prime. The x value would become a 3, the y value stays the same. So over 3, up 1, and that would be R prime. And then the last one, the x value is the opposite, the y value stays the same, so it would be over 3, up 1, 2, 3, 4, 5. So this becomes S prime. So I'm going to connect my points. And there is this figure reflected over the y-axis. Now we're going to look at reflecting it over the x-axis. Now when we reflect something over the x-axis, the x-coordinate stays the same. The y-coordinate is the opposite. So P prime would be negative 2 stays the same. Y would be the opposite, so it would become negative 3. So negative 2, negative 3 would be this point here. And that would be, actually, we would label it P double prime, since we already have a P prime on our graph. Now let's count and make sure that that's correct. I'm 1, 2, 3 spaces away from the x-axis this time. So now P double prime should be 3 spaces. 1, 2, 3. That is correct. So we're going to keep following our rule. So the x value stays the same, so this is going to stay a negative 2. The 1 becomes an opposite, so negative 1. Negative 2, negative 1. So that would be q double prime. And then the r would be negative 3. Y value is the opposite, negative 1. Negative 3, negative 1. And this would be r double prime. Last one, s would be negative 3. And then y would be the opposite, negative 5. So negative 3, negative 1, 2, 3, 4, 5. And then that would be s double prime. So we connect our points here. Not the straightest line, but it'll work. That is reflected over the x-axis. So just an important point to make, a reflection creates congruent figures. Remember, congruent means equal. They are the exact same size and shape, just a new location. So here you can see that C is the same distance apart from this line, B is the same distance apart, and A is the same distance. And it does not change the size or the shape of the triangle. All right, with these practice problems, I'd like you to follow the directions. First one, reflect JLK over the y-axis. 2, reflect ABC over the x-axis. And the last one, I want you to tell me what reflection has happened here to go from QRS to Q prime R prime S prime.